This is a pretty confusing problem, but once you do one, you can't really miss it. So let's do one. We're going to find the steady state matrix for the absorbing Markov chain represented by the matrix of transition probabilities P below. Okay, really that's a fancy way of saying that we're going to take P, we're going to multiply it by this vector x. We want to make sure we find all the values such that I get back this vector x. And the vector x is just x1, x2, x3, x4. So it's going to keep those vectors in place even if I multiply by the matrix P. All right, so let's go ahead and get started. What I'd like to do then is just write out the actual equation that we're going to solve. And here it is. All right, so, well, I didn't write that very well, but you get the point. Now I'm going to convert this into a system of equations by multiplying the matrix P by this matrix X. All right, and what I end up getting, because this is let's see, it's a 4 by 4, and this is a 4 by 1, I end up getting a 4 by 1 back, and I'm going to set that equal to these particular values in this matrix over here. You'll see how it works. So if I multiply the first row by this column in the vector, I end up having 0.5 x1, and everything else gets destroyed, x2, x3, x4. Well, that guy has to equal x1, because that's this guy right here, right? Okay, now doing the same thing over and over, I get 0.5 x1 plus x2 equals x2. I get 0.4 x3 plus 0.5 x4 equals x3. I get 0.6 x3 plus 0.5 x4 equals x4, and we always have the additional condition that x1 plus x2 plus x3 plus x4 will equal 1. All right, now let's turn this into something we can actually work with, because I've got to pull all the x's onto the same side, and we'll do that down here. So I end up getting 0.5 x1 minus x1, and that means I have a negative 0.5 x1. That's going to equal 0 because I'm going to move the x1 to the other side to subtract. And I won't say too much about these other things because they're done the same way. The x2's go away because I'm subtracting this x2 from this x2. A negative 6x3 plus negative 0.6 x3 plus 0.5 x4 equals 0. 0.6 x3 minus 0.5 x4 equals 0. And of course we have our original x1 plus x2 plus x3 plus x4 equals 1. Now this is ugly as it is, but if I turn it into an augmented matrix and put it in my calculator, that's really easy to row reduce. So I get 0.5, 0, 0, 0. Let's see how many zeros. Yeah, and another 0, but that's my solution, right? Or my answer. 0.5, 0, 0, 0, 0. 0, 0, negative 0.6, 0.5, 0, 0, 0, 0.6, negative 0.5, 0, 1, 1, 1, 1, 1. All right, good. Now here's the fun part. And I might even have to change papers because I seem to have run out. Let me find another piece of paper for us. Now, oh, I taped it so it would move. Hold on just a second. These are all the backstage things you're not supposed to see, right? All right, here we go. Now we're going to continue on this piece of paper. I'll try to keep it. I'll try to keep it so that you can see. Now, once we have this matrix, what I'm going to do is just go ahead and put that in my calculator. This will be a nice way to remind you how to use the calculator. And so what I'm going to start with is I'm going to go ahead and edit my matrix. Let's see what matrix I have in here. I have a 4 by 2. That's not going to work. That's from a different problem. So the matrix I need is a 5 by 5. And I'm going to row reduce this using the calculator because it'll take too long. Negative 0.5 for the first one, 0, 0, 0, 0. Do I have enough zeros? Yeah. Yes. I have 0.5 here, 0, 0, 0, 0, 0, 0, a negative 0.6, 0.5, 0. I have 0, 0, 0.6, negative 0.5, 0, 1, 1, 1, 1, 1. That's my matrix. Now, second quit, I'm going to check my matrix. So to check it, I just go back to second matrix and look, there's my new matrix stored in the 5 by 5. Let's go ahead and just list what A is. Oh, can I see? Yeah, I can see all of them, okay, except for that last piece. So I'm going to check, yes, sure enough, the first one is fine. First row, second row, fine. Third row, just right. Fourth row, perfect. Fifth row, outstanding. Now what I do to row reduce this is I go into matrix, and under math, I go down to row reduced echelon form. That's the command I want. See, that's waiting for me to put a matrix in there. Well, I could just put B in there, but I'm going to go to the matrix B, right? Oh no, it's matrix A. I stored it under A. I'm not sure what I said B, but the matrix A is what I want to do into row reduced echelon form. And sure enough, I get this sort of ugly thing, right? Now, the secret is that you don't want to give me as answers on a test decimals because they're inexact, right? You need exact answers. So what's great about, I don't have to play around to figure out what 1.3 or 1.8333 repeating is as a fraction. I can just go to math, hit the math menu right when that matrix is in my memories, my calculator's memory, and I hit answer to frac, and it's going to give me this entire matrix as fractional entries. Okay, I don't know why. Yeah, there we go. So let me go and write this down on my new piece of paper. So if I were doing this on a test, although you can't do this problem on test 1 because you won't have a calculator, right? So I can't give you something like this that would take so long. But I would say row reduced echelon form, and that gives me, so my grader knows that I use the calculator, right? And I'm going to go ahead and write down what I get. Here's what I get. And then I have 2 rows of zeros, right? Well, of course, that tells me I'm going to have a parametric solution. So now, remember, to retrieve this stuff, these columns represent my different entries. Okay, so this, I didn't mean to put a bar over that. These are my x1s, these are my x2s, these are my x3s and x4s, and then I have finally my solutions, right? My answers. So I have to convert these back to equations. Well, x1, 1 times x1 equals 0. Oh, nice. Okay, that's kind of nice. Now, what do I know about x2? x2 plus 0x3 plus 11/6 x4 equals 1. Well, that's the same thing as saying x2 equals a negative 11/6 x4 plus 1. I'm sure you can figure that out, why that's true. Now, x3, you can just do it by inspection here. I've got 1x3 is equal to, or plus, sorry, 1x3 minus 5/6 x4 is equal to 0. And so if I solve for x3, I get x3 equals 5/6 x4. Well, that's nice. And then I don't have any information on x4, so that must be my my free variable, right? Now, this is not the way to leave your answer. You've got to write everything in terms of your parametric variable, right? Your free parameter. So x1 equals 0. x2 has to equal a negative 11/6 t plus 1. x3 equals 5/6 t, and x4 has to equal t. And that's the solution, right? What does that mean? That means that the matrix X, which I was looking for, is 0, 1 minus 11/6 t. What else? 5/6 t and t. And that is my answer. Notice that I got an infinite steady state matrix, right? There are an infinite number of them. And so infinite. How do I know that? Because I've got a free parameter in there, and t can be anything, any real number. And so the other thing I'm going to say, so this is my answer, right? Some of you missed this, I noticed, on the homework because you rounded these decimals. That's a terrible reason to miss it, but remember, we want exact answers when we can. So these are the exact answers, so do not round, right? And we have found, I'll tell you what we were trying to do. We were trying to find the steady state matrix, and there it is.